This video is brought to you by the ILC. This question mentions something called the mean value theorem, so we're going to have to know what that is. The mean value theorem can be defined as follows, and we'll use a visual example in order to define it. So we have a function here, and let's say we have an interval from a to b. On A and on B, our function has some function values. So it might have a function value right here and a function value right here. In between, the function is doing something. We don't know what. Just a little sketch here of an imaginary function that we made. We just made this up, not representing this function, our f of x here in particular. This is just an example. Now, we're also going to assume that the function is continuous over the interval, because the mean value theorem only applies to functions that are continuous and differentiable between a and b. So we're assuming that this function is continuous and differentiable between a and b. Then what the mean value theorem states is that the slope of the secant line, and we're going to draw the secant line in red here, between a and b can be found along the line as a tangent line. The tangent line right here might be about there. And notice that the blue line and the red line are parallel. That means they have the same slope. And we're going to call the point at which this happens C. And the mean value theorem says there is at least one C value in between A and B. Notice it says find the number C guaranteed by the mean value theorem. All right. Now, to start this off, we might want to find out what is the slope of the red line. That way we can find the equivalent slope in our blue tangent lines there. To find the slope of the red line, which is just a secant line, is the same thing as the average rate of change, m, which is y2 minus y1 over x2 minus x1. So we have 4 variables to find. Luckily, we actually already have 2 of those variables. We know that x1 is equal to 0, and x2 is equal to 4. Just the numbers given to us right here. y1 and y2, let's get that 2 to look a little better here, y2 are just the function values of x1 and x2. So we take our x1 and our x2, we plug it into f of x. The square root of 0 is 0. The square root of 4 is 2. Once we have all 4 of these, we can plug them into our slope equation to find that m is equal to 2 minus 0 over 4 minus 0. Or in other words, 2/4, which is equal to 1/2. Alright, so we know the slope of our blue line, our red line is 1/2. The blue line has an equivalent slope, and the blue line is a tangent line. The slope of a tangent line is just the derivative. So we're going to take the derivative of our function, f of x, in order to find an equivalent slope. This is the square root of x, which we can rewrite as x to the 1/2 in order to take the derivative better. F prime of x, we can just use power rule on this, and we'd get 1/2 x to the negative 1/2. Oops, get that 1/2 looking a little better. Which can be rewritten as 1 over 2 square root of x. Now that we found f prime of x, we want to make sure that it's equal to the slope we've already found, our 1/2, our m. So we'll set this to 1/2. When we solve this equation, and we're going to use c instead of x now, because c is the variable of our function, we get 1 over the square root of c equals 1. To solve this equation, we would just take the reciprocal of both sides, have the square root of c equals 1, then square both sides to find that c equals 1. 1 squared is 1, after all. Now that we found the c value, we've answered the first part of part A. It says find the number c guaranteed by the mean value theorem. This also asks, however, for us to find the equations of the secant and tangent line. The secant line is just a line connecting these 2 points, the red line there. Thus, we can say that we can use the point slope form in order to find it. And this is point slope form right here. We'll be using this for both the secant and tangent line. The m is the slope of the line, which we know for both of them is 1/2. They should be the same slope. And the x2 and x1, or excuse me, x1 and y1 are just the coordinates of any one of the points. Now I'm going to pick the first point right here for the secant line. That it's y minus 0 equals 1/2 times x minus 0, which is the same thing as y equals 1/2 x. So the secant line is pretty easy here. The tangent line is really similar. Y minus y1 equals 1/2 times x minus x1. We just have to find out what is x1 and what is y1. Well, x1, as you can tell on our picture here, is just c. So c for us is 1, so it's x minus 1. y1, however, we're going to have to take our number and plug it into our function. So I plug it into the square root of x. The square root of 1 is just 1, so it's y minus 1. What we get then is y equals 1/2 x minus 1/2 plus 1. I've distributed the 1/2 and added 1 to both sides. Next, I can just simplify and I have my secant line. Or excuse me, my tangent line. Alright. This answers the entirety of part A for us. We can answer part B simply by finding the c value on this equation right here, which is different, but the process will be incredibly similar. So for part B here, let's copy down our equation, which I believe is f of x equals x cubed plus x minus 4. And the interval is from -1 to 2. First things first, as we did before, we're going to find the slope of the secant line. That means we're using our y2, y1, x2, and x1. I know that x1 is equal to -1, and x2 is equal to 2. That means that y1 is equal to f of x1. So I take my -1 and I plug it into my function, f of -1, which is the same thing as y1. And I have -1 cubed plus -1 minus 4. And you can plug this into your calculator. I'm going to do it by hand, personally. I would have -1 minus 1 minus 4, which is just -6. y2, same process, except this time we're using the second x value, which is +2. Which is 2 cubed plus 2 minus 4. In other words, 8 plus 2 minus 4, which ends up being +6 this time. So we have -6 and y2 as +6. Our slope then, our m, is 6 minus -6 over 2 minus -1. 6 minus -6 is 12. 2 minus -1 is 3. Thus, when we divide them, we get 4. Alright, so we found our slope. Now we need to find out where does the derivative of the function equal that slope. First, we have to find the derivative of the function, f prime. F prime of x would equal 3x squared plus 1. Notice, the 4 goes away because it is a constant, and derivatives turn constants into 0. Now we need to set this equal to 4, so 4 is equal to 3x squared plus 1. That says that 3 is equal to 3x squared, or that x squared is equal to 1. I've divided by 3 and switched the sides. That tells us that x is equal to plus or minus 1. Whenever we take the square root of both sides of an equation, we should put a plus or minus on one of the sides, usually the side with the constant. Recall that this was all in an effort to find c. So here we have two numbers though. Is that possible? And the answer is yes. So we can have multiple c values. We can have c1 and c2 as we call it. In fact, in the diagram we made earlier, this actually has two c values. Notice that if I drew a point right about here, the tangent line would also be parallel to our red line there. So we'd have a second value. We'd call it maybe C2 and call this one C1. So we can have multiple C values. Then the question is, are -1 and +1 in our answer here the two C values for us? And the answer is actually no. So while we can have multiple C values, there is a restriction on those C values. The C values can be neither A nor B, and in fact have to be between the two of them. You'll notice here that our x values, -1 and 1, that we found as solutions to this equation, -1 is A, and thus we cannot use it. If it were outside of our interval from -1 to 2, we definitely couldn't use it, because then it's not in our interval. So in other words, we only use the positive version, or C equals 1. Since the question doesn't ask us for tangent lines or secant lines, and we found the C value, which is what they asked, then we are done.